Okay. All right. It might take a little while for the YouTube stream to catch up with what I'm saying, but let's get started. So yesterday I was going through the climbing stairs problem, and I recorded the video pretty late or pretty early in the morning. And I was having a look at it. I rewatched the video again. I noticed a lot of things. Specifically, I noticed as the notes. I noticed I was jumping into the code without thinking through the how to approach it. That was one. And another thing I noticed was I got the base case very wrong. And it wasn't until like 27th minute I realized I got the base case wrong, and it wasn't until like 31st, like the last few minutes of the video, that I realized, hey, this problem is very similar to Fibonacci problem, which is quite revealing. I should be able to do a Fibonacci problem at this age. But yeah, what you witnessed was the rusty part of my brain. But fret not, we're gonna polish it up. And I was doing a lot of another thing that I noticed was I was doing a lot of trial and error. I mean, it is all right, and programming essentially just trial and error. I just print something. So how I used to do development is usually just print something and then see what the output is. But this one requires thinking like 5, 6, 7 steps, probably more. Think a lot of steps ahead and realize what's going to happen, like how we're going to catch that edge case and so on. And if you look at this code, there are a lot of still this is the final one that I submitted, but it still exceeded the time limit. But as you can see, we have got like useless variables here that we're not using. It's not necessary. Just return when n equals to 0, and then we can use memorization, just like how we would do in Fibonacci. And that is something I don't remember now. Okay. All right. What else? I think I don't have anything else. Oh, and we have fixed the flickering issue that we had in the first video, first stream. Let's sort it. And I learned a lot when I was watching myself, talking to myself. It was an interesting experience for a narcissist like me. A fun one, I might add. But besides that, I realized, and I was able to, I watched it right after I streamed the video live, so I was, the problem was still in my memory, random in my RAM, and I could identify the exact moments when I realized things. It was interesting, especially the moment where I realized the base case was wrong. It was fun to watch. If you want to watch that, you can go to the 27th mark, 27th minute, 27 minutes mark of the video, previous video. So I have not picked up a problem to solve for this video yet, but let's just go through something. And I don't think I'm touching this for now. Yeah, this is something that should be fun. Climbing stairs. So what are we doing with this? Ideally, we should revisit these problems and perhaps do it much faster. Then you could just attempt to do the memorization, implement the memorization part. Yeah, I shouldn't be looking at this solution because I'm gonna remember it. Maybe I'm giving too much credit to my memory here. But I hope the audio is really alright. Is it too soft? Yesterday I realized I was just kind of mumbling my way through the most of the video, and I don't want that to happen. Not that I care, but I just want to ensure the production quality is top notch. So let me check that. Let's increase the audio so I can hear myself. Okay. Alright, it seems like the audio is coming in for the live stream. And maybe perhaps I should pull this closer. Okay, so let's move on to the problem. This is a pretty interesting problem, and it's an easy one, so it's gonna take me a few hours at least. Okay, given the head of the sorted list, so it's starting at 4:33 p.m. Given the head of a sorted list, delete all duplicates such the element appears only once. Return the sorted list as sorted. This is yeah, this is. I could use 2 pointers for this. Yeah, and this is one of the mind-bending questions. Like, you have to keep track of the pointers. Next pointer equals current pointer equals to root, and then root pointer dot value is something else. So it can be mind-bending, but it's pretty straightforward for our problem theoretically. All right, let's see. Yeah, we can use 2-pointer method for this. What we can use? Okay, we want to have a root pointer, and then what? Pointers. Okay, root, and then another pointer previous, the pointer current. Now for current, we need current equals to head dot next. Okay, so while current, if prev dot value equals to not equals to current dot value. Okay, so what I should do instead of before I start writing code is explain how the algorithm will work in theory. So what we are implementing is keeping track of 2 pointers. One is the pointer that keeps track. So we have like 1, 2, 3 pointers, which keeps tracks of root, so that in the end, when we finish traversing, deduplicating the list, we can just return it, the root. And so the other 2 pointers are the iterating pointers. So we'll be keeping track of the current node, which actually we don't need that. We can actually just use the head. Right. Yeah, okay, so then let's just use head. Wait, what? I mean, it's okay. Let's just keep this. It's confusing. You know, we won't be touching the head variable after this, I assume. Yeah, we won't. Okay, anyway. Should be the current. Yeah, okay, I can just keep while head is not. Next. Next. So we need to be sure if head dot next is none, return, what is it? Return head. So when there's only one element in the list, you can just return the head. Otherwise, you just say previous, and head will be the current node, then head dot next is the next node, and then previous node is this, and then previous node dot current is not equals to head dot next dot value, and if previous node not equal to current value, what we do is link rev dot next equals to head dot next. So when the current, so the syntax makes it kind of difficult to understand this. So you can see, like, we have to repeat so many head dot next, but if you just use the current, that'll be slightly easier. But anyway, let's keep that in the RAM working memory and then work on it. I think I'm just mumbling at this point because I'm not sure what I'm doing, to be honest. Okay. I hope the audio is clear and you can hear my beautiful voice. Right, what is it? Head dot next dot val, head dot next. On like, I've got like this random thought. If I die, people probably will be watching this. Interesting. Anyway, so head dot next. I mean, I'm having problem focusing this. Oh my god. What do you have? Head dot next. Head dot next. And people will be judging, like, look at this guy, he can't even fucking deduplicate a linked list. Yeah, I can't. Yet. Okay, so if it's not, we just link the head to next, previous to next. So which will be the same? In this case, prev is equals to head, and then it's the same, and then prev becomes. So then we change the pointers. Previous node becomes head dot next, and then head dot next becomes head dot next. Wait, what? Pref becomes next, pref becomes head, and then head becomes the next node. So it's probably easier if I could draw this. Maybe I should get a tablet, the digital tablet, for drawing purposes. Content producing. Since I'm a content producer now, I should get a tablet. Perhaps nothing cheaper than like $100,000. some professional. Yo, I made 3 videos so far. Um, so the previous node A will be equals to the current node, and then the current node will be equals to the next node. So you're just iterating over to the next one, and we won't be linking. So let's say in the next iteration, the values are the same. We won't be linking it. Okay, okay, that's a problem. So if it's okay, so this only should happen. This should only happen if we should only change the previous node, head of the previous node, if the current value equals to non next value. So in this case, this is the previous node, this is the current node, and then so we check the value. It's not the same. It is the same, so we don't do anything. And then we just skip to the next node. The head becomes this, the previous becomes this, and then the values are not the same. So what we do is previous dot next, we link it to number 2, and then we will get this, and then we update the node. Give me a second. Sorry about that. I had to run, settle some stuff. I think we spent way too much time on this. Apologies. I don't think anyone's watching, so am I apologizing too? Anyway, so we move on to the next item, and then there's the pointer becomes, so the current pointer becomes, the previous pointer becomes 2 and the current pointer becomes 3, not the same, so it links, which remains the same. And then we change the previous to current, and then this is the current, and then we change the next to 3, and okay, I think that might be a problem. Yeah, I think there might be a problem, and and on the last note there won't be a next. So if it's a duplicate, yeah, we should do this. If head, and then oh my god, okay, this is where you need to trace through a few steps ahead. This is one of the things that you need to do, is think ahead a few steps and edge cases. So when you're whiteboarding stuff or having an interviewer, we probably won't have the ability to just compile and run. So you just have to trace through it in your mind, which is not impossible, but it will take a bit of exercise, mental exercise. So what we can do is basically for the last node, I can do what we are doing here. Okay, so for the last node, there's probably more elegant way to go about these, but let's just stick with this for now. If previous dot wall not equal to head dot next dot wall. Okay, so there could be two possibilities. If head dot next wall is not or not the same, we can just do that. So what we're doing is, if it's okay, let's say the current next, oh no, this is not, if it's not non, this is not gonna, it's not gonna enter at all in the first place. So why am I adding that? Okay, so we add this node, will we be here even? Head dot next is none, so we will exit the loop. Head dot next is this, and then previous is 3. Okay, so we might have to account for that manually. If head dot next if head, and then if previous dot value is not equals to head dot value, then we link it, and then return the root. So this is to handle the trailing node. Probably we could do something like if head if head, while head. Yeah, we could probably incorporate these into this, but I'm not sure. I can't trace through my mind, and I think I've already took too much of the recording time. So let's wrap this up. It's hitting the half an hour mark, so ensure it's working, thankfully. Okay, so let's submit. I think, yeah, head is none. Okay, if head is none or head dot not is none, just return wrong answer again. 1 to 1. Yeah, okay, this is not dealing with the edge case. Okay, let's screw this. While head, if previous dot value while head head dot next will be no. Okay, so I should have done this earlier. Head dot next is none, or so we just link that thing. Does that make sense? I'm not sure. Okay. Okay, let's imagine the first case. Current, previous, current. Okay, current here refers to head.next. Previous current, and current dot value is equals to result value. So we don't link it. Okay, this loop will end. Then if head is still true and previous, yeah, this logic here doesn't make any sense. Maybe you can get rid of it. I don't know. Even then, this doesn't make sense. Does it even work without it? It works. As you can see at this point, I'm just brute forcing my way, which is not very wise. Previous current dot head dot next, and head dot next is none. Okay, so what we have to do is we have to remove the link. So in this case, there's already an existing link between these two, and we're not removing the link. Like, we should change else we need to set prev.next equals to null. So we just terminate the link. There's no attributes. Wait. Not only non-type is no object next. Okay, so your ability to solve this problem will be really important. And you need to learn how to solve. So at this stage, I'm kind of stuck. I don't know what to do, and like, I'm just stuck. This is interesting. And I don't think I would have been stressing out this much if I'm not live. So being live kind of puts the time pressure on me, which is helpful and not helpful at the same time. Not helpful right now, but will be helpful in the real interview when it's a real thing. Okay, so let's just trace through this. I've tried tracing through this, and I just keep falling through. Previous. Okay, start from the first one. Don't go, just skip steps. First one. This is the root. This is the next. Head.next. Okay, head.next is not equals to anything, so it will exit. Okay, that's where the problem is. So it won't even enter this loop because head.next is none. But if we still have an head, we're not terminating the link properly. If previous dot value not equal to head dot value, previous and head are the same at this stage, same number, so this won't do anything either. Okay, so what do we do? So let's assume the current node is this. I think we need to fix it at this level. Head. While there's a head, this will terminate that next. And else prev dot next equals to none. We have to do some link removal here. This kind of fixed the previous solution, but this is not the way to go about it. So prev.next equals to this. We only change the previous to current head, and then we reset the prev.next to none. That is, I'm just brute forcing. Okay, I don't know. What's the solution? Yeah, this is a simple solution. Look at me. So instead of looking for previous the solution, they're looking for the next value, and if current is not null and next not null, so they can be one, wait, and not null, so current or next value equals to, so it just keeps one value. It's not using two pointers, just keeps that note. Else current equals to, else it just iterates. Okay, so how do we fix the one that we have here? Okay. So, well, we have the head as well as there's a thing next to it. I don't think it should work. We won't terminate the thing properly. Previous and the pointer from previous. And prev.next equals to none. Let's see if anyone has anything. Why does two while? And current.next if current.value equals to current.next. We are just skipping, but what about my approach to this is somewhat similar. So they're not changing the head at every iteration. They actually are. See here. Wait, the order in which they change is different. Does that even matter? Yeah, I can change. So this one, you can just move this to the end, and for this you just replace it with second.next. Yeah, pref.next is not, and then you just move it to, that's what we're doing here. And we only, okay, so this is what they're doing basically. The second one's the head, and previous value not equals to value, we change, then we change the pref equals to current. No, we don't change if it's not. Oh, I see this. Wait. I'm embarrassing myself. Previous.next. Okay, let's look at the pictures. The pictures usually, okay, I should draw this. I cannot trace this in my head. Okay, if previous value is not equals to current value, we just not equals to is not the same, and then we update. We only update the previous if the values are not the same. Fair enough. And then we iterate the head. Once the previous value, we skip, and then next. Okay, no, previous. So this is in the case. What's the problem? Okay, wait, let's submit. No big problem. Well, how long have you been live? You've been live for almost 50 minutes. Probably less if you exclude the brief interruption. But still, this problem shouldn't take this long. I'm feeling hopeless. At this point, I'm just staring at things. Okay, alright. So first, previous dot next equals to head dot next. Okay, we're doing this, but they only iterate. No, they. Okay, so one thing they're doing differently is. Come on, why are you taking forever? One of the things they're doing different is doing else equals to prev equals to hat. Is it? So first dot next, first dot next equals to next second dot next. Okay, that's fine. And then this one is interesting. Why they are doing this? Else, if wait, what the hell? What the hell? If it is the same, the skipping. Had oh my god. At this point, you guys don't have to watch this. I know this is painful for me. This is painful. Does this even work? Fucking hell. They're not even covering the base cases. But what they are doing is this one. Okay. Okay, let's try that. That's the root. But this fella is giving the head itself. Okay, the head remains unchanged, so we don't need the root. What we can do is previous equals this, current equals to head dot next if head else none. Okay, so we'll get this. So while there's the current exists and current dot value is not the same. Okay, if it's same, what we do, we just move on to the next one. So what happens is current dot current we don't update the previous, so if it's the same, we just update current equal to current dot next. We just skip to the next one. Okay, forget this. Else, if it's not the same, what we do is previous dot next equals to so previous value is equals to current value. We just iterate through it. But if it's not the same, we link the previous dot next to current. And then we still have to update current equal to current dot next, otherwise you're not going to move, right? Okay, so in this, well, what I was saying just now was we could actually refactor the code as in, okay, this is fine, first, second, blah blah blah. This can be moved out, and this can be next. Okay, so this is the same with the first one. The values are the same. What? The first pointer's value equals the second pointer. First one's, so we just cut out. Okay. So the pointer here changes. Ref dot next equals to ref current. Is keep. I think I would realize the problem. Before this, I only changed the pointer of the previous one if it's not the same. Here they're changing if it's the same, so it's updating the pointer. Okay, and then if it's the same, they just don't do anything. Jesus Christ. Yeah, you don't have to do anything because it's already linked. If it's not the same, you can just loop through it. Okay, that's smart. And then in the end you do current dot current equals to next, so you just move on to the next one. Should work. What the fuck? It should work, mate. This should work. Indentation problem. Everyone has that indentation problem. Why this is a problem? Okay. Run. Root is not defined. We're not updating head, you can just still give head. Yeah, go. This is ridiculous. Takes 48 minutes. 30 seconds. Okay. What did we learn? I think. So previously, code. Let's go and see if we can find it. Is it this one? Yeah. Previously, the code does not update the pointer of, it's very hard to say it in English. So previously the previous pointer was not being updated if the values are the same, but here we're updating the pointer even if it's same. We skip if it's same, otherwise no, we skip the pointer if the values are the same, otherwise we just loop through the next one. Okay, I hope it makes sense now, but back then I don't know, like, so the part, once you look at the solution, yeah, that's obvious, so you do that's that. But then when you are having that problem, the solution is not that obvious. Oh, it was not obvious to me, and it's still not obvious. How do you get from? Okay, so how? For example, it's a pathfinding problem. Like how we arrive there. Now, if you show me a maze and then you show, okay, I arrived through these, yeah, it makes sense. But then when you are at point A, when you want to get, and when you're at the start, how do you know if you're on the right track, or how do you know how to get to the end of the maze unless someone already show how to do that? It's difficult. Oh, screw that. Fuck that. Yeah, I think I don't have to be politically correct in my streams. I hope that's alright. Okay, so yeah, what we are doing before this, if the values is, so we keep track of the head. Actually, we can make this work as well. I just don't know how. The way is a opposite. The previous, we only update the previous pointer to the current pointer if the value differs. It's a different approach. Let's see if someone else has, or maybe I could spend a bit more time to figure out. Yeah, this guy. Excuse, this guy's just keeping. But our solution, you keep track of 2 pointers. I believe we can make this work if you take into account of the edge cases. Alright, it's going past 1 hour mark. I'm gonna stop this. I'm gonna take a break.